Where do we come from? How does life evolve? And is there life beyond Earth? Hi, my name is Kelly Girardi, and if you've considered these questions before, you're in good company. While no life beyond Earth has been physically found, a multitude of research has pointed to the possibility of microbial life, microscopic organisms like bacteria and archaea beyond Earth. NASA missions such as Perseverance on Mars, and even missions that are exploring remote and extreme places on Earth are starting to uncover the answers astrobiologists are seeking. And today, we're going to speak to the explorers who have traversed Earth's extreme landscapes, providing insights to the search for life beyond Earth. But before we hear from them, let's learn a little bit more about astrobiology. I am so excited today. In honor of Women's History Month, we have an all-female episode. So I am here with Dr. Darlene Lim, research scientist at NASA Ames Research Center, and Dr. Jackie Gordial, environmental microbiologist at the University of Guelph. Thank you so much for being here.
Thank you. Thank you for having us.
Thanks for having us.
Yeah, this is going to be great. I'm excited. There's so much to cover. So just to start with the absolute basics, can you tell us what is astrobiology?
Okay, so one way to look at astrobiology is to start just by breaking down the word astrobiology. So we have astro, meaning star, and biology, meaning the study of life. Bios is Latin for life. So astrobiology is the study of star life. It's the search for life beyond our own planet and beyond our own solar system in the universe at large. But astrobiology also concerns itself with the origins of life on Earth. How did life start here in the first place?
Amazing. I know both of you have so much experience in the field and also with field research. Can you share some of those experiences and tell us what is a day like in the life of an astrobiologist? Darlene, maybe we can start with you.
Yeah, absolutely. It's never a dull day. It's always exciting. You know, both Jackie and I have the privilege of really doing work that takes us all over the world, as well as into labs in different environments where we have to deal with people every single day. But some of the places that we do get to go take us, into extreme environments. I've been working most recently, actually, in the Big Island of Hawaii, as well as out at sea. So these are some images from a recent project called Basalt, where we were actually looking at microbial life in volcanic settings. This is some video from a deep sea hydrothermal vent just off the coast of where Oregon and California meet. And here we have an ROV, a remotely operated vehicle, deep, few kilometers underwater, actually collecting water and rock samples. And what we do with those samples is actually examine the chemistry and then the microbial populations that are living associated with the water chemistry and the rock chemistry. And we do that so we can understand life as it pertains to its, development here on Earth and how that might also be taking hold elsewhere in our solar system and beyond. So it's pretty fun every single day.
That's amazing. It looks like a lot of fun. Jackie, what about you?
Yeah, I want to echo what Darlene said. It's truly a privilege to get to see some of these wonderful extreme sights on our own planet. A day in the field is very busy and it's very rewarding. So you're looking at some photos here of one of my favorite field sites. This is in the McMurdo Dry Valleys of the Antarctic. It's the coldest and driest place that we have on our planet. You can see here, it just kind of looks like a barren desert wasteland almost. And a day in the field in this environment is exactly like this photo here, drilling through permafrost, this cold, frozen, environment to look for microbial life that may be surviving or even thriving in these cold, arid soils. This is considered to be a really high fidelity Mars analog. Mars is a really cold and dry planet. And so the work that we do in environments like this help us know, how and where we could potentially look for life on other planetary bodies such as Mars.
Amazing. And speaking of life elsewhere in the universe, what are the other ways in which NASA is currently searching for life elsewhere?
So I think you can sort of bin it into three different categories. One of them is, as we were just talking about, actually looking to our planet as an example for what might exist or could have existed in the past on other planets. And so we will actually go out into these analog field settings, as you see some video here, again, from another analog site in Idaho, and conduct work that helps us learn about this planet as well as others. And then there are other things such as missions. So spaceflight mission, ground-based missions that allow us to observe our solar system and beyond and understand the extremities of the chemistry and the habitability potential of other systems. And then there's sort of a third bin that I would bring up, and that is the laboratory. That's where we can actually move into a controlled environment and do some very specific experiments so that we can really understand how life might actually find the potential to proliferate and take hold and so forth, and how it might actually survive in the extreme conditions of space and beyond.
They're all great examples. And we know so much of this research, all space research, in fact, starts right here on Earth. But why is it important for us to look inward when we're looking for life elsewhere in the universe?
Yeah, that's a great question. So right now we know of one place that life exists, and it's in our own backyard. It's our planet here on Earth. And so we know that life has originated here on Earth. And so this is a great place to start looking. We look at Earth to look at, looking at the origins of life, looking at analog environments to our own early Earth, places like hydrothermal vents that Darlene works at, but also surface environments like hot springs are potential candidates. We also look to our own planet to understand the limits to life on Earth. So we look in cold places to know what the cold limit of life on Earth is. What's the hot limit of life? Knowing the constraints to life here on our own planet will also help us constrain where and how we look on other planetary bodies.
Amazing. I know I'm not the only one with questions for both of you. We have a lot of people at home who have questions for our expert guests, and we want to hear them. Join the conversation and ask your question by writing in the comment box wherever you're watching this, or using the hashtag AskNASA on social media. So let's just jump into a few. So our first question is from Zoe Spikes on Twitter, who wants to know, what has been your coolest discovery? Or what is a discovery that encourages you to continue your research?
I have one right off the tip of my head. So that footage that you saw earlier in that cold desert environment is also the place of my coolest discovery, which is a site on our own planet where we can't seem to detect active microbial life happening right now. So many of you know microorganisms exist almost everywhere on our planet. We have to try really hard to actually get rid of them. We have to sterilize bottles, etc. And so that site, this really cold and arid site, was, the site of, the first permafrost site on Earth where we couldn't find active microbial life. We knew there were microbes there because we could see them with a microscope, and we could actually even sequence their DNA. But we couldn't get any hints that they were actually active. And instead, it looked like they were all dormant or, in a state that's very similar to when bears go into hibernation. That discovery led me on a whole rabbit hole of other environments where microorganisms that are dormant seem to be the norm rather than the exception. And that's really since then the direction that my research has been going in.
Amazing. Do you want to add anything, Darlene?
No, I mean, first of all, I think that's fantastic. And every time we go out, you know, the discoveries happen, and sometimes they can be very grand and be very noticeable, and other times it's sort of a progression. And I guess that's something I just wanted to highlight for some of our younger viewers out there, is that it does take time, you know, to come to that moment where you're just like, aha. And for me, my career has gone from, you know, strictly looking at astrobiology related questions to now moving into science operations. And some of the projects that I work on are actually very heavy around how you organize people so that we can actually influence flight missions in real time. And so, and actually incorporate science into those decision-making processes. So these are some images of us working in one of those analog settings where we incorporate human exploration alongside and, you know, closely coupled with science. And we're doing that in anticipation of missions such as Artemis coming online. And of course, you know, looking forward in time to when we have humans exploring the surface of Mars. So we're really trying to understand, how do you design systems where you can have scientists sitting on Earth interjecting into the process of discovery and science. And that's really been itself, you know, a really incredible process over the last couple of decades.
Yeah, absolutely. And speaking of process, I love this next question. Mason on Facebook wants to know, what is NASA's protocol if there is confirmed contact with intelligent life? Who wants to take that one?
Wow, that's it. With intelligent life. Well, that's really interesting. So I do not speak for NASA in this answer, but I will say there is likely a protocol. I think a lot of different groups have ideas on what those protocols should be. Certainly to be friendly would probably be a good thing. You know. But I think everything does come back to protocol. And so, you know, the question totally hits the nail right on the head in that there has to be preparation and readiness for the opportunity that, you know, that may present itself in the future.
Yeah, absolutely. Later on in this episode, if you're watching, I'm going to ask both of them if they believe that there is life elsewhere in the universe. So you'll want to stay tuned to hear their answers later. But next, we have a question from Dan on Facebook, who wants to know, where's the nearest planet that is most like Earth?
I actually think, so I was going to say, you know, I think Mars is the planet next door, and there are a lot of features of Mars that are very similar to Earth. So Mars is this cold and dry planet now, but in the past, Mars was a little bit warmer, a little bit wetter, and a lot more Earth-like than I think many people think about. So I would say that the planet next door is one of the most Mars-like, or sorry, the most Earth-like.
Definitely. And speaking of sort of Earth-like conditions, Ricky on Facebook wants to hear a little bit more about conditions on Antarctica. Any thriving, extraordinary life forms that exist in those conditions?
I can answer this one as well. So in that desert, in the McMurdo Dry Valleys, the microorganisms are really the star of the show. There aren't birds that fly into the area. There aren't plants. There's no moss. Microorganisms really are the only life present. One of the coolest life forms in this area are organisms called cryptoendoliths. So breaking down that word, crypto means hidden, endo means within, and lith means rock. And this is microbial life that's hidden inside of the rock, and you can't see it from the outside. You could walk past one of these rocks, you would never know that it's teeming with life. But if you were to take a rock hammer, crack it open, you would see bright green bands of photosynthetic organisms that are using energy from the sun to photosynthesize carbon compounds and support entire communities of microorganisms. That's exactly what this photo is. It's cracking open one of these rocks to find the life that's teeming inside.
Amazing. I know there are a lot more questions. Remember, you can join the conversation too. Ask your question by writing in the comment box wherever you're watching this, or use the hashtag AskNASA on social media. We will be right back with Darlene and Jackie to answer a few more questions. But first, let's take a look at the other ways NASA explorers are venturing to extreme environments for science.
I am Morgan Cable, NASA scientist.
That's Morgan.
She's probably one of NASA's best spokespeople for exploring our solar system's icy moons.
Europa is a fascinating place. It has this liquid water ocean that's about 3 times the volume of all of Earth's oceans combined. That's a lot of water.
Although Europa isn't the only icy moon in our solar system, NASA has identified it as one of those places with key astrobiological potential. Morgan is a collaborator on the Mapping Imaging Spectrometer for Europa, an instrument selected for Europa Clipper, NASA's next mission to Jupiter's icy moon. She's preparing future NASA missions for success on the surface of alien worlds. In 2018, Morgan and her colleagues were in the field studying how life colonizes in fresh lava.
Earth, it turns out, has a lot of excellent, what we call analog environments, places that are similar enough to some of these other worlds that we can conduct some tests and we can do some analyses here. Now, they're not perfect, of course. They're not going to be exactly like Europa, but we can still learn a lot by testing in these environments. Some of these places include Antarctica and the Arctic Circle, but there are other places too, Alaska, Greenland, even Iceland. Any place where you have a lot of ice, because guess what the surface of Europa is made of? A lot of ice.
We haven't found life beyond Earth yet, but there's a growing body of research that indicates there could be microbial life in our cosmic neighborhood. Morgan and her team make it possible to both appreciate the life we have here on Earth and seek new life in our solar system, yet to be discovered.
Awesome. So we have a ton more questions, as you might expect, but before we get to those, I'm wondering, how did each of you get started in these exciting careers? What inspired you to pursue this field of research? Darlene, maybe we can start with you.
Okay, thank you for that question. Really, I have to show my gratitude towards so many of the women and the men in my life that have been very gracious and generous in bringing me into their world, into the professional community that I'm now part of, and also for sharing their knowledge with me when I was younger, and then really nurturing my career as it went. But then if I look even further back in time, I have a lot of gratitude towards my parents who were immigrants to Canada, who really wanted to embrace the new country that they had just come to. And we spent a lot of time fishing and camping and just exploring outdoors. And I think that imbued me with a love for observation, for the natural world around me. And that, of course, has stayed with me to this very day. And that's pretty much what I've made a career out of. So I feel very fortunate in that realm to have, moved in that direction and had the life I've had.
Absolutely. Jackie, what about you?
Yeah, I would say my path into astrobiology is one of luck, very similar to Darlene. I was really, really lucky enough to have great mentors. I actually didn't know that the field of astrobiology existed until I was an undergraduate. There were no astrobiology courses at my school, and it wasn't until I happened to be doing research, microbiology research in polar environments, and I had a mentor who was very into astrobiology, and these mentors really guided me and introduced me to this field, and I quickly fell in love with it and have been in it ever since.
Well, I am so excited for all of the folks who will come behind you in this really exciting field. So before we get into everyone else's questions, I just have to ask, do each of you believe that life exists elsewhere in the universe? I'm just going to have to put you on the spot. Yeah, I'm getting nods. Yes.
Yeah, I think that sums it up. That's my hypothesis is yes. And, I think it's guiding a lot of activities right now to try and make sure that we go out and test that hypothesis, both, near field and far field. So it's an exciting time to be in planetary science and in astrobiology.
Amazing. Okay, so jumping into everyone else's questions now. Our first one is from Scotty Justine on Facebook, who asks, how much optimism is there about life on Mars specifically?
That's an interesting question. I think optimism translates to motivation in the scientific community. So the fact that we have so many missions currently operating on Mars, that have operated on Mars, and that just started operating on Mars, should give you an indication as to the amount of enthusiasm and energy and motivation that is just permeating throughout our community. It's a very exciting landscape to explore. a lot of people have also thought about this landscape on Mars through the lens of analog work on Earth. So there's a lot of research that's been done to get us to this particular moment in time. And I think we're really seeing a lot of just enthusiasm around capitalizing on all the knowledge to date and then trying to build forward from there. So yeah, I think the answer is it's a good time to be in this field.
For sure. And Patrick wants to hear a little bit more what those life forms could be like. Do you think that we will find life that's not carbon-based or maybe doesn't require liquid water?
That's a great question. We have astrobiology targets such as Titan, which, there are lakes of hydrocarbons. Could there be life on a place like Titan that uses another solvent, instead of water as hydrocarbons? These are questions that astrobiologists are asking. And I think, many things are fair game. But as of right now, we don't know of any of these life forms, of course.
Yeah, absolutely. Kuwait on Facebook wants to know, where do you think is the best candidate for extraterrestrial life?
Well, I think if we consider within our solar system, and if you're looking to answer the question from an existing, life form perspective, then I would go to some of the ocean worlds that we're pretty excited about. Europa and Enceladus is an example. Jackie just mentioned Titan. I think, again, when we think about the previous question around enthusiasm and motivation, there's just so much data that's been built up. We've also had other, flight missions that have gone, for example, there's Cassini, there's Juno, that's generating data that gives us a better sense of how to strategize and get ourselves ready for missions that will take us into these environments and then allow us to really interrogate it properly, to look at the hypothesis of, yes, there is life that's existing in our solar system right now beyond our own planet.
So I know both of you are professionals and experts in this field, but Arlene Metter on Twitter wants to know, do you have examples of a science fail where you made a mistake, something you can laugh about now?
I think laughter's good, right, Jackie? For everything. It's just like...
Yeah, I mean, so many that I can't even count.
Right.
I have, just silly mistakes that I've made of mislabeling something or making a calculation for some kind of reagent and, forgetting to carry a zero and completely screwing up an experiment. There are also science fails, like one time we had a freezer that broke down on a long weekend, so no one was around to hear the freezer alarms going off. We lost very precious samples. It was devastating at the time, but now it's, it is laughable. It wasn't a huge deal in the grand scheme of things.
Yeah, definitely. Yeah. Anything to add, Darlene?
Well, I think that's so well put. And what, just coming back to the job that we do, we work in analog environments, and we're here on Earth, we're studying the Earth, but then of course in anticipation of studying other planetary systems. But when we work here on Earth, we're actually also afforded the ability to kind of make mistakes that are far more costly and impactful if you're making them in a singular flight mission, to Europa. So mistakes are just part of the job and you have to live with it. Of course, with that comes anxiety. And so, again, for all the younger listeners out there, I think just knowing that you're going to make mistakes and you have to make mistakes in order to later on understand and, how to move through things better. That's just part of the program. And anxiety just means that you care. So, and you care intensely. So it really is baked into the profession, if you will, to make mistakes and have a little anxiousness about the whole thing.
Well said. Debbie on Twitter wants to know, what part of the world do you work in most?
I work the most in Canada here. So Canada has a lot of really cold environments. We know a lot of our astrobiology targets are also cold environments. So I work the most in the Canadian high Arctic.
I think I've sort of worked all over the world, to be honest. And I used to work a lot in Canada during my graduate program, primarily in the Canadian high Arctic. But since then, I've sort of had the opportunity to work all over the place, as well as underwater, on desert, on land. And there's just so many different opportunities. You just have to figure out exactly what it is you're interested in, what your specific question is, and then go to the right place and make sure that place is safe, that you can get to it, without compromising anyone's safety, and then you can make decisions from there. So we're very selective and careful about where we go. But certainly there are lots of interesting places right in our own, planetary backyard, if you will, to explore.
Yeah, absolutely. Okay, Pascal on Periscope wants to know, what does a regular day as an astrobiologist look like?
Pre-pandemic or during pandemic?
Clarification.
Yeah. Go ahead, Jackie.
Well, for me, it typically looks like actually either being behind a computer or being in my lab. So a lot of the work I do is extracting DNA or genomic material from environments. So that takes place in the lab. There's a lot of experimentation that goes with that in the lab. But once I get my data back, a lot of that is just crunching those numbers and looking at those DNA sequences on my computer. That's where I spend the vast majority of my time. Yep.
Yeah,
Amazing.
ditto here. For when we go out into the field, a lot of times that's the moment in time that gets aired, through the press, or just generally people tweet about when we're in the field. So it seems to be the part that garners the most attention. But in fact, about 92% of our time is out of the field. It's getting ready to go into the field. So it's a lot of what Jackie said. You're in front of your computer, whether it's and you're with your data, or you're working with people. We're in meetings now, video conferences all the time. So it's a lot of personal interactions trying to build processes so that we can tackle these really tough questions. And then when you get into the field, that is certainly where all that hard work kind of has to play out. It's, very much like getting ready and training to get into that intense moment in time where you really do have one shot to get it right.
Yeah, absolutely. So we have about 30 seconds left, but a lot of people are asking and wondering, what do they do in order to become an astrobiologist? So really quickly, Jackie or Darlene, do you want to give them some advice?
Follow your dreams. There's so many ways to become an astrobiologist, and it's such an interdisciplinary science. So if you're interested in chemistry, even anthropology or biology, follow that passion in whatever path works for you.
Yeah, I think Jackie says it really well. So many different entry points.
It's exciting. I'm sure there are going to be a lot of astrobiologists to come who are inspired by both of you. Unfortunately, that is all the time we have today. Thank you so much, Jackie and Darlene, for joining us.
Thank you.
Thank you.
And thank you to everyone joining us at home. If you'd like to learn more about NASA's search for life beyond Earth, visit astrobiology.nasa.gov. You can also follow along on social media on the NASA Astrobiology accounts on Facebook and Twitter. To learn more as NASA researchers venture to extreme and interesting locations on Earth for their work, follow NASA Expeditions on Facebook and Twitter. We are thrilled that you could join us as we talked with some trailblazing women dedicating their careers to finding life beyond Earth. Happy Women's History Month, and thank you for joining us. Until next time.
So we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
world was changing quickly.
Well, it really was a perfect storm. We had a lot of technology